Hello, hello, good afternoon, everyone. So today, me, Ayush Srivastava, and my colleague Divyang Saxena is here to present a session, a knowledge session on custom ML model deployment using AWS SageMaker. So let's. So before moving on to the session, before starting the session, let's keep in mind our knowledge etiquettes. So the knowledge etiquettes are punctuality. We should be punctual and joining the session before 5 minutes. Before 5 minutes prior to the session time, and so that we can start on time and we can conclude on time. Second is feedback. Make sure to submit a constructive feedback for all sessions, as it is very helpful for the presenter. The third point is silent mode. Keep your mobile silent in the silent mode. Feel free to move out in case if you need to attend an important urgent call. And the last point is avoid disturbance, avoid unwanted chit chat during the session. And if you want to ask any questions, we will be having a separate Q&A session in the end. All right. So as for our agenda for the day, we will be starting with a brief description of what is machine learning and its life cycle. Then we will be going to what is SageMaker and regarding what is SageMaker and why are we going to use it and its functionalities. Then we will be discussing regarding the benefits of AWS SageMaker, why are we deploying our models in AWS SageMaker and the benefits of it. Then fourth point, we will be moving to how does SageMaker works and the functionality of it. If somebody wants to use case SageMaker on their own project, we will be demonstrating that. Then after that, we will be deploying our custom ML model. So at first we will be discussing some theoretical points, and then we'll move on to the demo part where we will show from scratch how we can deploy a purely custom ML model. And then yeah, then the last is the demo part. Okay. So let's start with first what is machine learning. So as we can see, according to Arthur Samuel, so machine learning algorithms basically enable the computers to learn from data and even improve themselves without being explicitly programmed. So what this basically means in simplified way is that a computer without being explicitly programmed to do certain things, we can basically train our computer using machine learning so that it can automatically perform some prediction classification or whatever task that we want to perform it we say it to perform. So as soon as I'll give some of the examples, you will be able to understand it more clearly. So as you can see, a few day-to-day applications that we commonly use machine learning is image recognition. So an image recognition is like, suppose you have your phones and inside you have face detection. So this was originally developed by Facebook. So that is also one aspect of machine learning. Then the second is speech recognition. So for speech recognition, we also use it in our day-to-day life, such as Alexa, Siri, uh, um, uh, and Cortana, these type of things. So it is correctly able to understand identify our language and understand our human language. Then the second is product recommendation. So such as when we watch or shop something on Netflix or Amazon, it it generates product recommendations. So that is also done by machine learning. So these are some use cases. And the last one is virtual personal assistants, such as I told you, Siri and Cortana. So what they does is they will be able to perform certain tasks as we instruct them to. So that is also done using machine learning. So these are some really cool features. And so in general, let's move on to machine learning lifecycle. So in general, a machine learning lifecycle looks something like this. So at first, we will be getting a raw data set that will be stored either in a data lake. That could be either AWS, GCP, or whatever cloud platform. And then we will be basically cleaning our data. After cleaning our data, because why we need to perform the cleaning? Because our data set is usually very dirty and contains many anomalies. Then we will be doing feature engineering so that we can so that we can select the features that are important. Then we will be splitting our data into the training part and our new data. So new data is basically a testing data, so that we'll be performing tests on that our machine learning model hasn't seen. So for the training data part, we will be applying machine learning algorithms and we'll be training our model to do certain tasks. Either it could be classification, it could be many different things. And for testing our model, we will be using the holdout data or the new data that we have put out separately to test our model and evaluate our model. So on the evaluation part, if we attain certain threshold, such as a certain percentage like 90%, 30%, we will be able to see whether the model works perfectly or not. And then we will be able to then we will either retrain it, or we will try to improve the model, or we can finalize it. Now let's come to the main part is what is AWS. So Amazon Web Services is an on-demand cloud platform. It is offered by Amazon that provides service over the internet. And so AWS services can be used to build, monitor, and deploy any applications type in the cloud. So it is basically lets us build, monitor, deploy any type of application, such as not even machine learning, like any type of application, and all of these things are done on the cloud platform. And so that makes it very accessible for everyone. And even and one of the main parts is, so this is where AWS SageMaker comes into play, because AWS SageMaker is a subpart of AWS. Now, so AWS is broadly adopted cloud platform that offers several on-demand operations like compute power, database storage, content delivery, etc., to corporate and scale and grow. So basically, what does that mean is basically according to your need, you can scale your database storage, you can scale your own compute engines, and you are also not dependent on your current physical current system requirements. You can assign a higher power machine, you can assign a higher power CPU or GPU, and so that you can perform whatever task you are going to perform easily, and you can scale it. Now let's come to what is Amazon SageMaker, the main core part of it. So Amazon SageMaker is managed service in the Amazon Web Service, that is AWS, in the public cloud. It provides the tools to build, train, and deploy machine learning models for predictive analysis applications. So it can be predictive, it can be classificative, it can be classificative, and so these type of things are all possible by AWS SageMaker. And the platform automates the tedious work of building a production-ready artificial intelligence pipeline. So it also supports the automation of whole machine learning model, and so that we can deploy it very simply using the UI that our AWS SageMaker provides. The second point is deploying ML models is challenging even for experienced application developers, and Amazon SageMakers aim to simplify the process. So that is the main point that I was discussing. So the main UI that AWS SageMaker provides make it very simpler and easier to navigate, so that we can deploy and build our models according to our needs, and scale it properly. And one of the more important features that is recently introduced is that Amazon SageMaker also supports AutoML. AutoML is supported, and so what is AutoML? It is basically the process of automating the tasks of applying machine learning to real world problems. So what does AutoML means is that, whenever we are trying to make a machine learning model, we will be choosing certain algorithms. Then after training our model on certain algorithms, we will need to tweak the algorithms get a uh, to get a certain outcome, or an outcome accuracy percentage. So what AutoML does is it helps us to automatically choose basically our model, and perform the hyperparameter tuning task, so that we can automate these processes, and we don't need so that our data scientists and our developers don't need to interfere in this process. So we can also do this in AWS SageMaker. So now the main part is some of the benefits of using Amazon SageMaker. One of the main benefits it is highly scalable. So according to your need, suppose you want to build a simple project, or suppose you want to build a very high demanding project, you can easily scale it. By easily scaling, you can increase the data storage size, the CPU size. So these type of things can be increased, and can be managed on the fly. So the second point is it helps in creating and managing compute instances with least amount of time. So suppose you want a certain type of machine learning algorithms. Let's take an example of TensorFlow. So for creating that, you will be needing to install multiple libraries and multiple Python environments. So you don't need to do that. SageMaker does it very simply by providing you uh, a certain Jupyter instance that has already these things pre-installed, so that you can basically start working on it with like least amount of your time wasted. The third point is it helps in storing all the ML components in one place. It is mainly a part of AWS SageMaker along with AWS. So all the ML components in which your data set can be stored in similar AWS services like S3, and your ML models can be stored in ECR. And they can be easily integrated using AWS SageMaker. the fourth point is that all your logs get easily stored in CloudWatch logs. So one of the main features is that you don't need to write separate log file for your whenever you up your endpoint. So basically, so it will generate your cloud logs automatically. The fifth point is Amazon's own pre-built models are highly optimized to run on AWS. So that is one of the main parts is that if that Amazon also provides certain algorithms and certain models that are already built by Amazon, and they are highly optimized to run on AWS. So what in turn that does is it provides those models can be trained very faster and very faster, and they can be tuned and they can be also automated using the AutoML. And the sixth point is maintains uptime. Process keeps on running without any stoppage, so you don't have to basically after you basically initialize an endpoint, you don't need to constantly maintain to check whether the model is working or not. So that process can be run that can be, it could be kept running indefinitely according to your need, and it provides high data security because AWS is a secure platform, so as we all know. So yeah. Third is less.
Hello, Ayush.
Yeah,
Yeah, in the last slide you said we can store our models in ECR.
yeah.
So
So
are
algorithms.
we okay? Algorithms. So are we storing them in a image, in a container image or something?
Yeah. So basically what is happening is like our data sets will be automatically stored by SageMaker in S3, and our algorithms, whatever algorithms that we are using, will be automatically containerized by AWS SageMaker. We don't need to do anything. So it will be automatically containerized and it will be stored in ECR.
Okay.
Yeah.
So it is done by a SageMaker only.
Yeah, it is done by SageMaker only.
Okay.
Okay, now so let's move on to the how does SageMaker actually work. So SageMaker has like basically a simple process of if you want to create a simple project using SageMaker or SageMaker and SageMaker's inbuilt models. So the first step is building/train. Then the second step is test, tune, and deploy. The last step is deploy. So the following diagram shows how the machine learning works. Basically, we'll be building or training our model, creating our instance. Then we will be testing and tuning our model, and then finally, when we are satisfied with the test results, we will be deploying our model. Now here comes the part for train. Now, so AWS SageMaker helps developers to customize machine learning instances in Jupyter Notebook. So as you can see in the below image, you will be able to create a separate Jupyter Notebook instance. So what a Jupyter Notebook instance is, it is basically an IDE that you can basically use certain algorithms. You can use it like a simple IDE, and you can install multiple whatever algorithms and whatever use cases that you want to do that you do in a certain IDE. Okay, give me 2 minutes. Yeah. Okay. Sorry, there is a power cut, so okay. So let's resume. So second point is it provides more than 15 widely used ML algorithms for training purposes. So as I told you, like it contains multiple inbuilt algorithms that are provided by AWS SageMaker. So and that makes the training and everything very faster. So it is also supported. And if you want to use only those algorithms, you can use these in this uh, in basically the Jupyter instance that you created. Third is it gives the capability to select the required server size for your notebook instance. So as I was mentioning earlier, that you can select certain CPU sizes, or and you are not limited by your own computer's physical requirement. So you can select like how like whatever amount of storage you want, whatever amount of CPU power you want. So depending upon your task for machine learning models, you can basically change it and create it easily. And a user
Ayush,
can yeah.
sorry, I think this slide is not visible. Is it only for me or for all?
No, I think it's not visible for me as well. Ayush, can you
Yeah,
reshare that?
from
Yeah. Let me share. Okay, I hope my screen is visible.
Yes, it's now.
Okay. So yeah, so as I was telling for the last point, a user can write the code for creating model training jobs and using so basically using our notebook instance. And so for creating notebook instance, the UI in AWS SageMaker makes it very simple. You can just create a notebook instance, and we will be seeing more of it in our demo part. Okay. So one of the other things that I was telling about that we can choose certain type of pre-built environments. So this is basically after creating a notebook instance, a user can select the type of environment that he will be using, as shown by here, such as MXNet, TensorFlow, Python 3, Python 2 environment, Conda 2 environment. And suppose if you want to use, suppose you want to use R language, you can also use that. And so the necessary libraries that will come pre-installed according to whatever notebook instance that you want to choose, that you are choosing. So this makes it very simpler, so that you don't have to install all these libraries again and again. The second part comes for the tuning part. So at first we will be setting up our imported libraries that are already set up. If you want to install certain other libraries that you want to utilize, you can import them, and then we will be defining environment variables and manage them for our training model. So in the environment variable, we will be basically defining our hyperparameters that we'll be using. So train and tune the inbuilt SageMaker algorithms by tweaking the hyperparameters according to your need. So so as I told you, the hyperparameters are basically used to tweak our machine learning models, so machine learning algorithms, so that we can attain a better result. So let's see. So as you can see, hyperparameter is basically achieved by adding suitable combination of algorithm parameters that are usually different from that usually vary from algorithm to algorithm. So as we can see here, here we are assigning a hyperparameter for XGBoost algorithm that is provided by SageMaker itself. So as here we can see, we have provided max interrupt, ETA, gamma, main child. These type of so according to these, we will be able to define our hyperparameters and manage them on the fly, and then we can call the estimator method, and then we will be able to mention it, basically reference it in our model, so that our model can basically can use these hyperparameters. So yeah. Now the last part comes is testing. So
this
testing
is
it,
random forest.
which
Sample
no XGBoost.
XGBoost. Okay.
XGBoost. So this is XGBoost one. So let's for testing. So the last part comes is testing. It helps us to manage it helps us in managing the model performance by using manual testing. So we can do normal manual testing, and we will be able to evaluate the accuracy of our own models. It also helps us to make sure that we have achieved losses acceptable for your task. So for the testing purposes, we can use like cross validation, or like certain like false positive or true positive or over classification rate. We can use these type of things to basically, and we can design our test according to our need. So suppose you want to use cross validation, you can basically use and create your own test. And it is and it also provides, after testing, it also provides, because it is a Jupyter instance, it provides the results on the fly, so you can check it without finishing your endpoint. So yeah. So now the part comes after you have tested our model and you're satisfied with the result, the deployment part. So once the tuning of the model and the testing part is done, the models can be deployed using SageMaker endpoints. So deploying our models can be very simple. So whatever model that you have provided, you will save it in the name of XG. So right here we have saved it with the name of XGB predictor. And so the only thing that we have to do is that we have to basically say XGB.deploy function, deploy method, and then we can basically deploy our model according to whatever instance type that we have selected. Here we have selected the large instance type, so we can deploy it makes it very simple one liner to deploy it. It usually takes a little bit time to deploy the model. And yeah, so now we can now evaluate your model and determine whether you have achieved your business goals. And you can check after deployment, you can check through Postman or whatever methods you want to test it. To test your endpoint for prediction, you can use Jupyter Notebook instance. Yeah, okay. same. So okay. Now the main question arises, if you don't want to use the SageMaker models here, because here we have seen that we are using SageMaker's inbuilt algorithms and SageMaker's whatever algorithms that our SageMaker has provided, and because they are highly optimized. So the question arises, what if you have a trained model that is outside SageMaker, that model is trained outside SageMaker, can you still deploy it? And the second question is, what if you want to utilize certain algorithms or frameworks that are not supported by SageMaker instance? Is it possible to basically deploy them and to deploy that ML model? And the third question is, what if you want to create a REST endpoint to deploy your custom model and test it using like maybe Postman and different kind of different kind of interfaces? So the answer to all these questions is yes. So, and we will be basically, so this is we can deploy a fully custom ML model using using SageMaker. So it basically involves using three main key features. That is, first is SageMaker service, the second is AWS Elastic Container Registry, and the third one is AWS S3 storage. So we will be looking at like how we'll be using these different services in the demo part, and also later on. Okay. So yeah, so as we can see, so this will be a normal architectural diagram. So what we'll be doing is, whatever model or whatever dependencies that your program that you have created on your own personal systems or requirement, we will be saving we'll be containerizing that whole program along with its dependencies in a Docker container, and that Docker container image will be pushed into AWS ECR. AWS ECR, basically AWS ECR registry, so that the SageMaker can access it. And if you want to store your testing data and your training data set, you can also use S3 bucket to store your data. And one of the main features is that to make it more secure, you need to so basically you need to assign access key and secret key that can be assigned using IAM rules. And so these are the main three features that if you have all these three setups, you will be able to deploy whatever model that you have created, whatever custom model you have created through SageMaker endpoint. And then you will be able to exchange input and output from whatever end user you want. So there are certain requirements that you need to keep in mind if you want to deploy a fully custom ML model. The first requirement is Docker. So Docker is mainly used to basically containerize our program along with its dependencies. And so and then we will be using Docker to Docker containers in our ECR, and we will be uploading it in the ECR along with the dependencies, so that our SageMaker can reference it. For installation, you can use sudo snap install Docker. It is pretty simple. The second part is Flask. Flask is basically a web development framework developed in Python. So here we will be because we are deploying our model using the REST service. So we will be and one of the things that you need to keep in mind is that for health check, for our health check, SageMaker demands that we need to create a certain endpoint such as /ping and invocations. So these two needed to be kept in mind, and we will be discussing more in detail uh, in the next slides. And the last part is AWS CLI. So AWS CLI is required mainly to upload our containerized image that is on our local system to ECR. And you can do the installation using sudo apt-get install AWS CLI. Pretty simple. Okay, so now let's move on to the deploying fully custom model and the more in detail depths, and we will be switching to Divyank. Divyank will be taking these slides and performing and showing a demo. Divyank, you can take over. Hello, Divyank. I don't think your mic is audible.
Hello, am I audible now?
Yeah, it is audible.
Okay, is my screen visible?
Yes.
Yeah. So thank you, Ayush, for the brief explanation about the SageMaker. Let's quickly jump into the process of deploying custom machine learning model on SageMaker. So let's break the process into four simple steps. The first step is the building the model and saving the artifacts. Second is defining the server and inference code. We'll learn what is inference code and how to define an inference code. And build third step is to build a SageMaker container. And the fourth step and final is create model endpoint configuration and the create the endpoint. So let's move on to the step one, building the model and saving the artifacts. So here we are uh, training our model outside the SageMaker. As Ayush said, we are using open source RASA natural language model for this demo. So build the model and serialize the model, which is used for prediction. In this demo, we are using the RASA to train an LLM model. Once you have trained the model, you can save your model either in S3 bucket or normally in your opt/code directory. And remember one thing, you have to save your model in tar.gz file, gz format. So the next step is defining the server and inference code. So let me just tell you something about the what is inference code. In simple words, inference code is basically the entry point of your container. So there are some important things to remember about the inference code. We have to make two important REST APIs in this inference code using the Flask server or any WSGI server you want, like Flask and Bottle and anything other package, Python package you want. So it is very important we make these two APIs. First is ping API and second is invocation. The ping should be a get request and the invocation should be a post request. And the third thing to remember is that we have to serve uh, these two API on port number 8080. So inference code in the container will receive get request from the infrastructure and it should respond to SageMaker with HTTP 200 status code and an empty body, which indicates that the container is ready to accept inference request at invocation endpoint. And this ping or get request will be hit by SageMaker itself. So move on to the third step, the SageMaker container. So SageMaker container, as you already know, it utilizes the Docker container extensively, and we have to create a Docker container using a Dockerfile. It is a Dockerfile is basically a text document that contains all the commands a user could call on the command line to assemble an image. Like we have to define the Ubuntu version, like operating system version, the requirement that we have to install, like all the Python packages, and the environment variables that we have to set up. The otherwise. If we have to copy our code, like if we have to copy our all the project folder in /opd/code directory, which is very important. So we also have to define in the Docker file, and we have to expose the port number like 8080, which is very important. And the last thing is the entry point of our like container image. So this is very important that we need to copy the project folder uh, where you have to /opd/code and make it as a working directory, yeah, which is very important. And so let's move on to the next step. So how SageMaker runs your inference image. So basically it uses an entry point, the example of which it is right here. Like for example, entry point, we have to use the keyword entry point, and in the square brackets we have to use the executable and the parameter 1 and the parameter 2. Like executable we use Python, and whatever and the next parameter we will define what is the so the last step, creating model endpoint configuration and endpoint. So creating model can be done by API or AWS Management Console, providing model name and IAM role. So we just have to provide a model name and the IAM role configuration. We can create a new role, or we can use an existing IAM role. The next step is, after creating the model, we have to create endpoint configuration and add the model that we have created in the previous step. And then in the next step, we have to create configuration, and we have to uh, select the existing configuration that we have created in the previous step. Now in the final step, your custom model has been deployed, and you can hit the invocation API via Postman or any web uh, browser. So let's just quickly move on to the demo part. So we'll just start with the IAM role. First of all, we have to create a user. Now click on the add user and just type a username like demo user 1. Provide the programmatic access. Next, we have to create a group, name a group. And we have to find the policies. We are using two policies here. First is Amazon EC2 Container Registry full access, and the second is Amazon SageMaker full access. Amazon EC2. So first is this. It provides administrative access to Amazon ECR resources. And the second thing is Amazon Sage. SageMaker full access. It provides access to the management console and SDK, and also to the ECR, S3, and CloudWatch logs. So click on that and create group. Next tags. Tags are optional, so we can skip for now. These are the details for the user and group. So just click on the create user to create the user and its group. So now we can have the access key ID and secret access key. We can download the CSV file here. So we can close this. Okay. Now move on to the code part. Let's just first talk about the Dockerfile. So here is my Dockerfile. Here is Ubuntu version. I'm just installing the Python 3.8 version and Python 3 pip. These are requirements for my project. This is the environment variable. This is I'm copying the whole project Rasa app folder to /opt/code, and I'm declaring the working directory as opt code, exposing the 8080 port, and using the entry point as in this class. And I have created two, like I said earlier, two REST APIs. Like first is ping and the second is invocation. So in Ping API, it is get request and it is returning status 200. And in invocation API, it is reading the JSON input and retrieving the sentence that we are providing within the API in the Postman request and returning the response of the prediction of the model. So this is the inference.py and we are serving on port number 8080. So let's move on to the CLI part. So in the CLI part, we have to uh, change the directory to our project folder. So this is my project directory, dollars PyCharm project, Rasa deploy. Rasa deploy is my project name. And we have to configure the AWS CLI first. So you just have to install AWS CLI first. I have already installed it in my system. So I just have to configure it using the um, user policies like AWS. Now we have to enter our access key ID and secret access key. We have downloaded it here.
Divyank, I'm sorry to interrupt in between, but it's already 4:11 and we need to close sharp at 4:15. So can you please wrap up the session accordingly?
Yeah, sure. So we have to just configure this. Key. Region is same, J format is same. Now let's just move on to the Amazon ECR, where we have to upload our container image. So we have just to create a new repository. Just name a demo repo. Now to push our container image and to build our container image, we have to click on the view push command. Now there are 4 commands here to push the container image onto the Amazon ECR. So first we have to log in via this command. So as you can see, we have successfully logged in and we have to build our container image. It will take just a few seconds to build. Okay, so now next step is to tag image as a latest. The last step is to push our image to the ECR container. Okay, it is taking a lot of time, so we can move on to the next step. So after uploading the whole image, it will look like this. So here you can see the image tag is latest and you have uploaded successfully the container image. So we have to move on to the Amazon SageMaker. Here we have to go to the models and create a new model. We have to put a model name. Model XYZ. And we have to provide either an inference code image or the S3 bucket location of where your model is provided. So we are using the container image, so we will provide the path of the image.
Divyank, I'm sorry to interrupt again, but it's 4:15 and the next session we need to start. So can we please wrap up the session quickly now?
Yeah, okay.
Divyan, can you just show them the already deployed one?
Yeah, sure. So after creating model, endpoint configuration, and finally the endpoint. So you just have to create endpoint and select the endpoint configuration and predefined model. So as you can see here, the demo endpoint is up now and created successfully. We can now test via Postman. Like we have to copy this URL. Select post, select AWS signature, the access key, secret access key, and AWS region and all that. And inside the body, we have to provide the our input sentence as JSON. So we have to provide a key as input and sentence. Yeah, so here is the response. As we have sent that this text, please update the BL number, and it is classified as remove, update, amend, seal, and confidence level is 99 above 99%. And here are the entities, like update is the entity, and the second entity is HBLU, the ID, BL number that we have provided. So finally, it is our model is working, and we have shown you how to deploy a custom model on SageMaker. So thank you very much.
Right. Thanks, Divyank, for
Thank
the
you,
demo,
everyone.
and thanks, Ayush, for the wonderful session.